Light. Every day we wake up, turn on our lights, but how many of us stop and think about where the energy comes to power it? The purpose of today's discussion will be to talk about how we generate the electricity and energy that we use. Here we have a classical incandescent tungsten light bulb. The electricity flows, heats up the tungsten, and causes a bright light to emit. We will talk about fossil fuels, renewable energies, and different ways of storing the energy that we produce. Our goal will be to give you a perspective of how we generate the electricity and power used to power this light bulb and other sources of power consumptions that we use every day.
We use energy to do some pretty amazing things. Energy keeps us connected, lights our buildings, and moves us from place to place. The power output of a single human being is about 100 watts, and before fire, most of this energy came from food. But the average American today uses about 10,000 watts per person. And if you do the math, modern Americans use about 100 times more energy than our ancient ancestors. While few of us would like to go back to living like cavemen, our increased use of energy often has some unintended consequences. And though energy prices often make headlines, we pay for our energy use with more than just money. When pollution gets into our air and water, all of us are affected. Energy exists in many forms. Light energy, chemical energy, thermal energy, kinetic energy, and electrical energy are all important forms of energy that we interact with daily. Today, we are going to demonstrate some technologies that convert one form of energy into another. Some of these technologies are relatively new, whereas others have been around for hundreds of years.
Hi, so you're probably wondering how we generate electricity to power your light bulb or your computers. So we actually built a demo to demonstrate how electricity is being generated. And this is a hand crank generator that how it works is we will spin the wheel and it will generate some electricity and power the LED over here. And how this setup works is that we have little magnets right here, very strong magnet. So when we turn this wheel, the magnetic field will alternate. And we have a little coil over here to generate electricity. So when the magnetic field is alternating in the coil, due to the Faraday's law of induction, it will produce an AC current. And we are going to show this in action. So as you can see, there is a lot of work to generate a little bit of electricity. And actually, engineers have worked for decades to improve this efficiency.
Like the hand crank, this hydroelectric system works by turning a wheel. Water flows over turbine blades, which turns a shaft, and the shaft turns a generator, producing electricity. This electricity can be used to light up these LEDs. Water flows due to gravity. Overall, the potential energy is converted to kinetic energy by the gravity, and kinetic energy is converted to electricity by turning a wheel. This is a close-up of the generator, which we use in this system. As we can see, here are the turbine blades, which are turned by the flow of the water.
To generate electricity, we need to spin something. We've seen that with the hand crank generator and also with the hydroelectric demo. So aside from moving water, a way that we can spin something is using high pressure steam. And this is an example of a steam engine. So all that we need is some water and a source of heat. Sources of heat in industrial power plants could be nuclear reactions, burning coal, burning natural gas, burning oil. In this case, we're burning these small bits of cook fuel, which is also a fossil fuel. It's made from some sort of petroleum. It smells terrible, it smokes, but it generates lots of heat and lots of steam and allows this engine to work. If we remove the heat source, the engine dies down.
Here we have a parabolic dish that focuses the sun's infrared energy into one point and heats it above 600 degrees Fahrenheit. At this temperature, you can do several things. You can run a steam engine, or you can run a Stirling engine. Engines universally are the same, is you have some sort of temperature gradient. Here we have the temperature difference between the atmospheric air and the really hot air that's being heated due to this metal rod. So this parabolic dish only works when you focus the sun's energy to this point. So if I focus it directly to the sun, we should see it becomes very, very bright. And after a few seconds, this wheel begins to spin. Now, to demonstrate how hot this metal rod gets, I have just some water that I'm going to pour, and it's going to instantly vaporize. This is a Stirling engine.
Heat engines are a very popular and reliable way to turn heat into electricity. Heat engines have been around for centuries, but there's a newer technology called thermoelectrics that has been around for only decades and is used to turn heat directly into electricity. The way that's done is using a sandwich of two semiconductors. When we put a heat gradient across the semiconductors, the hotter side, electrons flow from the hot side to the cold side, and in the process, that creates a current that can power small electric devices. If we reverse the polarity and put a battery across it, we can cool things, so we can use these also as refrigerators. An important application for this technology is in space, where the Mars rover is being powered by thermoelectrics in its journey to Mars.
This is a photovoltaic module, a solar panel. Light incident on the front face excites electrons inside these silicon wafers. Excited electrons are then directed towards the two output terminals by carefully formed internal electric fields inside the material. Panels like this, made of silicon, are durable and relatively efficient, but expensive to manufacture. The expensive costs for making solar panels has led everyone, manufacturers, researchers, industrial people alike, into looking into new materials that are flexible, lightweight, and may even offer higher efficiency in the long run. Regardless of how good your solar panel is, or how good your manufacturing technology is, we're left with one question at the end of the day. How do we make energy when the sun doesn't shine?
So we've seen how we can use the potential energy in water to generate electricity in a hydroelectric dam type of operation. We can do the exact opposite thing in order to store electricity. So during the nighttime, when very little electricity is used, power companies will use electricity to pump water uphill and basically recreate the potential energy in that water. This can also be used to solve the problem of storing solar energy for nighttime consumption, because it's obviously only sunny during the day. So we have our solar panel, we just switch on this pump. And here we go. We're now pumping water uphill and effectively reversing a hydroelectric dam. And this is by far today the most popular and widely used form of energy storage for industrial power generation.
Here is very sunny and nice in California, but what happens if we don't have much sunlight, so we cannot generate much renewable energy at night? So one of the ways to store energy is actually through hydrogen. Hydrogen, when you provide electricity to water, it actually splits water into hydrogen and oxygen. And hydrogen has a lot of energy in it, so it can burn it to recreate electricity. So it's just like gas. You can store energy into gas and you can take it out again. And this is a setup that we have a solar panel which is providing electricity through this wire over here. And then through this negative electrode, it gives electrons to hydrogen ions. So you generate hydrogen molecules, and hydrogen molecules become bubbles and start coming up through this tube and going to this little beacon here. So you see the hydrogen bubbles over here. And to demonstrate that hydrogen has a lot of energy, we are going to blow this bubble up.
Our hope of this presentation is that by demonstrating different energy technologies, we have helped you to become a more conscious consumer of energy. Fossil fuels have greatly expanded our ability to communicate with each other, power things around us, and progress as a society. However, fossil fuels are a limited source, and their use negatively affects our health and our environment. For these reasons, the research and development of alternative renewable sources of energy are a necessary thing, and we encourage all of you to stop, think about what happens at the other side of this wire and how we produce our energy. Thank you.